Hi, Algebra Oneers. This is lesson 20, and you can turn in your workbook to lesson 20 if you want to follow along. We're going to do most of the activities, but not all of them. So again, if you want to pause the video, you can turn to lesson 20 in your student workbooks. Okay, so today we're just going to keep solving inequalities, guys. So that's the good news. We started solving inequalities the other day. We're going to keep that up. Okay, so let's look at this problem that we have. Kieran is getting dinner for his drama club. The budget for the dinner is 60. When I give you a budget, that means I can't go over it. So I have to be $60 or less. The first thing that I would probably do then is remind myself that that means I need to be less than or equal to $60 because I can't go over. That's a constraint. Okay. Now let's find out what else we know about the scenario. Kieran plans to buy some prepared dishes from a supermarket. The prepared dishes are sold by the pound, so each prepared dish is $5.29 a pound. And he also plans to buy 2 large bottles of sparkling water that are $2.49. And he's only going to buy 2 of them. So represent the constraints in the situation, and if I use variables, I need to tell what they mean. Okay. So eventually we're going to solve for how many pounds of prepared dishes. So first of all, this right here, how many pounds of prepared dishes, should be our variable. So maybe we might let P equal the number of pounds of prepared dishes, because that's what I don't know. I know how many bottles I'm buying of sparkling water. I don't know how many dishes I'm going to buy. So that's my variable. Okay, so let's set up our equation. So what do we know? We know that each pound, each dish, prepared dish, is $5.29 a pound. So we're going to take the price times the number of pounds. That's pretty normal. We've been doing that a lot. And then we have to add the 2 bottles of sparkling water, which are each $2.49. So I'm going to do that in my calculator in a second, but for now, that's me showing it. So I did 2 of those, and they're each $2.49. So I'm adding them together. That's going to be my total. And remember, I need that to be what? Less than or equal to 60, because I can't go over my budget. Whenever you have a budget, you need to be less than or equal to that. So I don't want to go over that. Okay. So there's my relationship, right? So here we go. And then it wants me to actually solve. Okay. So I'm going to go ahead and take 2 times 2.49 in my calculator. So this is 4.98. And then I'm going to start solving this. Remember, we did this yesterday. We said we're going to solve this just like it was an equation. So I'm going to subtract the 498 from both sides to cancel it out. So I have $5.29 per pound, less than or equal to. Then I have to do 60 minus the 498, which leaves me with 55.02. And then the last thing I would do to solve is to divide by 5.29. You're just dividing by that multiplier. So then I didn't divide by a negative, so my inequality stays the same. In my calculator, I'm going to do this divided by 5.29, so you guys are going to need that calculator out. Pause it if you need to. And I get about 10.4. This isn't perfect, but that's good enough. I know that I can only buy 10.4 pounds or less so that I fit within my budget. So one possible solution would be if I could buy, 9 pounds. That would work. I could buy only 6 pounds. I could even buy 10 pounds. All of those would be solutions because they would work. Okay. All right, so I'm going to skip 20.2 and I'm going to go to the 20.3. So if you want to get there, you can pause it. So there are some different strategies you can use to solve inequalities, and you can get the same solution. So I'm going to look at how these 2 different students solved this scenario. So let me make it a little bit bigger. Okay, so here's the original inequality, right? And it looks like both students started off by distributing, which is exactly what I would have said to do. So we're going to multiply each of these guys by 2. So that gives me 4x. 2 times 1.5 is 3. This side stays the same. Now, what you'll notice is, and you can do this many different ways, these students both decided to change it to an equals for now. So they started just by solving for when it was perfectly equal, and then they're going to figure out how it works afterwards. And then I'll show you another way off to the side to do this. Okay, so they distributed and they got to here. Okay, and then this person, it looks like they subtracted 18 and brought it over here, right? So if they subtract 18 on both sides, this became a negative 15, so they canceled out the 18. And then they subtracted 4x and moved it over to this side, which gave me a total of negative 5x. And then it looks like they divided both sides by negative 5. So Andre got x equals 3. Priya did the same thing, but she kept her x's on the left-hand side, which is how I prefer to do it and how I suggest you do it. So she added this x, see that? She added this x over here, and then she got 5x plus 3 equals 18. Then she subtracted the 3 to move the 3 over, and then she divided by 5 and got x equals 3. They both got when it was equal, but they have to finish solving the inequality, because remember, it was an inequality. So if you only solve for when it's equal, how do you figure out what your inequality should look like? Well, one way to do that is you can test a solution. So I'm going to pick something, I can pick something bigger or smaller than 3. It doesn't really matter. So let's say I'm going to try 4, which would be bigger, and I'll try 2. And only one of them should work, because my inequality should only go one way. So let's see which way works. Let's see if I want numbers bigger than 3. Do I want things headed this way, bigger than 3, or do I want things headed this way, less than 3? So that's how we're going to decide. So we're kind of like here right now. We're trying to decide, should it be less than 3 or greater than 3 for my final answer? Because I know 3 is the perfect equal. Okay, so if I plug in 2 to my original equation, I'm going to see if it makes it true. So I would have 2 times 2. Instead of an x, I'm going to plug in 2 plus 1.5. And I'm going to see if that's less than 18 minus, again, instead of x, we're plugging in 2. So I'm going to see if 2 works. So this ends up being 2 times 4 plus 1.5. This is 5.5 in here. And that makes this 11. And then this side is 16. So is 11 less than 16? Yes. So far, this looks like this one is going to be the one that works. But let's also try 4. So if I try 4, which is on the other side, I get 2 times 4 plus 1.5. 18 minus 4. Remember, I'm just plugging in a 4 for the x. This becomes 2 times, this is 9.5. This is 18 minus 4 is 14. This ends up being 19 is less than 14. What? 19 is not less than 14. So if you plug in something bigger and it doesn't work, then you can't be bigger. You have to be less than. So that would mean I have to be only things that are less than, right? I think this is a little bit intense. So what we did instead is we talked about how you solve it when you need to flip the inequality. So I'll show you what Andre did, but I'll show you how we as a class would solve it to make it work. So let's look at what Andre did. So if I do Andre's version, but I leave the inequality, so I'm going to leave my inequality. I would distribute 4x plus 3. I'm going to leave my inequality. See, he used the equals, but we're going to leave the inequality. He moved the x's over here. Again, I don't like that. I would never suggest you do that, but that's how he solved it. So I'm going to show it to you. So then we have 18 negative x minus 4x gives me a total of negative 5x because I'm just adding those together. And then we're going to subtract the 18 to bring it over. So I get negative 15 is less than negative 5x. And so the problem here is he would finish solving this by dividing by a negative 5. And remember, we said if you divide by a negative 5, you have to flip the sign. So this comes out to 3, but then you have to flip the sign. And so then you get this. Now this is written backwards, right? Because the x is on the right. So if you want to switch this, you have to put the x over here and then flip the sign. That's why I don't like solving and having the x on the right-hand side. So what I'm going to tell you guys, so that's why Andre's works, just to show you how Andre does get the correct answer. I do not suggest doing that, guys. So I'm going to show it to you in the way that I suggest you do it. So let me clear this off. I would do it like Priya. Always, always, always keep your variable on the left. Okay, always. Trust me, it will make life so much easier. So I'm going to solve this one more time, leaving the inequality. So I'll distribute first, but I'm going to move my x's to the left. So instead, I'm going to move this x over by adding it. So I'm going to add it here. So I get 5x plus 3 is less than 18. I have to move the 3 over because now I'm going to try to get x alone. So I'm going to move that 3. That gives me 15. And then I'm going to divide by 5. Now here's the cool thing. This time, what I was dividing by wasn't negative, so I do not have to flip the sign, and this guy is ready to go. So trust me, keeping it on the left means you have a lot less work to do. So I highly suggest doing that. So here's some inequalities. Let's try them together. Try solving them and see, do I have to flip the sign? Do I not have to flip the inequality sign? So let's start with A. So in A, what do we do to get rid of this fraction on the left-hand side? We can multiply both sides by what? Yeah, 5. So this 5 will cancel, and it just gives me 1p. I don't need to write the 1, but it technically is a 1p. I didn't multiply or divide by a negative, so I don't have to flip the sign because this was a positive number, and I get negative 10 times 5, negative 50. So there's my answer. Remember, it's only if the thing that you're multiplying or dividing by is a negative, and it's not. It's the only time you have to change the sign. All right, let's look at B. First thing I'm going to do in B is distribute. You bet. So I get 4 times x. 4 times 7 is 28, less than or equal to. Multiply. 4 times 2x is 8x. 4 times 8, 32. If you want, you can pause the video and try it, and then start it up again. Okay, again, for me, I'm always going to bring my variables to this side, which means I'm going to move this 8x over, which means I have to cancel it by subtraction. So let's see what we get. 4 minus 8 is negative 4x. Everybody else stays the same. Then I'm going to move the 28 to this side. So to cancel it, I need to subtract. And I get 4. And then what's my last step here? Divide by negative 4 on both sides. Now, because this was negative, I'm going to flip that inequality. This becomes x, and then 4 divided by negative 4, careful, positive divided by negative is negative, and it's negative 1. So we get x has to be greater than or equal to negative 1. All right, let's look at C. C is negative 9n is less than 36. This one is easy to solve. I only have to do one step. What do I have to do to get n by itself? Divide by negative 9. Oop, there's a negative. We're dividing by a negative. Gotta flip the sign. This becomes n. 36 divided by negative 9 is negative 4. There you go. All right, and D, I have C over 3 is less than. I'm going to distribute this side, so negative 2C, and then negative 2 times negative 7 is positive or plus 14. Okay, what can I do to both sides to get rid of that fraction? You bet, multiply both sides by 3. Make sure you multiply each term. This one, the 3's cancel. That's the whole point, so we get C. The number I was multiplying by was not negative, so I don't have to flip the sign. 3 times negative 2 is negative 6C, and 3 times 14 is plus 42. Okay, now let's move our variable over to the left. Remember, we always want the variable on the left. So I have to cancel this out by adding a 6C. So I get 7C is less than 42. Final step, divide by 7. This was not negative, so you do not need to flip the sign, and we just get C is less than 6. Okay? All right, in this next one, we just want to match the inequalities to the solutions. So what I would do to match them is to actually solve them. So let's do it. So number 1, if I tried to solve number 1, I would bring these x's to the same side. So I'm going to subtract 3x, and I get, ooh, look, 0 and 3x. What would you divide both sides by? 3. So you get x is less than 0 divided by anything is still 0. So this one should be x is less than or equal to 0. So find the one that is on 0, because that's like the number that I'm using. So this isn't, let's see, the only one that's on 0 is f. Let's make sure it makes sense. Less than or equal to, if it's allowed to be equal to, it should be a closed point on 0, and then it should be everything smaller. Yep, f. Okay. Let's do 2. In number 2, I have 1/4 x is greater than negative 1/2. Okay, what am I going to do to get rid of that fraction? I'm going to multiply both sides by 4. Okay, might need your calculator for this one, but that's fine. This just becomes 1x. I did not multiply by a negative, so I don't have to flip it. Remember, it's only ever if you multiply or divide by a negative. And then negative 1/2 times 4 ends up being negative 2. Again, you should be practicing plugging that into your calculator. Okay, first of all, I'm looking for the point that's at negative 2. And it should be, since it's not equal to, this should be an open circle. So let's find negative 2. This is the only one that has an open circle on negative 2, and it says x is greater than. Yep, this is everything greater than. So that was E. All right, for 3, we have 5x plus 4 is greater than or equal to 7x. Okay, guys, this is one of those where it might look like it's easier to move the x this way, but I'm telling you, move it this way. So I'm going to subtract 7x because I like to move mine over here. I get negative 2x plus 4 greater than or equal. What happens when I cancel this? 0. Then I got to move the 4 to this side, so I'm going to subtract it. Negative 2x is greater than or equal to 0 minus 4 is negative 4. What's the last step? Yep, divide both sides by negative 2. Now, I divided by a negative, so I'm going to flip my inequality. And then negative 4 divided by negative 2 is positive 2. Should this one be an open or closed circle on 2? It's equal to, it's allowed to be equal to, so this should be a closed circle. So you're looking for a closed circle at 2. Both of these have closed circles at 2. But there's only one that can be things less than. This is less than or equal to. So the one that's the numbers that are less is this guy, headed that way. So this would be B. If you want to pause it and try the next 3 on your own, you can. I'm going to go ahead and do them. All right, number 4 is 8x minus 2 is less than, I'm going to go ahead and distribute negative 4x plus 4. So I distributed. I'm going to bring my x's to the left, so I'm going to add that. 8 plus 4 is 12x's minus 2 is less than 4. I'm going to add 2 to move that 2 to the other side. I get 12x minus 6. The last thing I need to do is divide by what? 12. Now that 12 is not negative, so I don't flip it. And I could reduce this fraction. This 6 over 12 reduces to 0.5 or 1/2. So I need to look for the graph that matches with being less than. Should this be open or closed? This is not or equal to, which means this should be an open circle on 1/2. And then it should be everything less. So let's see, this has a circle at, I'm looking for, here we go. This one has an open circle at 1/2 and it's everything less. So this should be D. Okay. Again, you can pause it and try it on your own. Number 5, 4x minus 1 over 3 is greater than negative 1. Very first thing I would do is get rid of that fraction, that denominator, multiply both sides by 3. On the left, these two things cancel. That's the whole point. So I just get 4x minus 1. Over here, I get negative 1 times 3, negative 3. Again, the number I was multiplying by is not negative, so I don't flip it. It's only if you divide or multiply by a negative. Okay, I already have the x's here, so I just have to add 1 to both sides. Negative 3 plus 1 is negative 2. I'm going to divide, to finish, I'm going to divide both sides by 4. Remember, this number you divided by was not negative, so I do not flip the inequality. And this is negative 1/2. So what does this say? This says x is everything bigger or greater than negative 1/2. Should this be open or closed? Since it's not or equal to, we can't include 1/2, so it should be open. Let's go back up and look. We're looking for 1/2, negative 1/2, excuse me. So negative 1/2, here's our open circle at negative 1/2, and yep, it's everything bigger. So that should be A. All right, last but not least, number 6. Ooh, number 6, 12 over 5 minus x over 5 is less than or equal to x. Now the cool thing here, I know we have denominators, but everybody's denominator is a 5, so we're going to go ahead and multiply both sides by 5. And here's the cool thing. Remember, you technically have to multiply every piece here, but this one is going to also cancel. This one, see how the 5 here cancels with that, so you get 12. And this one, the 5 cancels, so we just get minus x. So the 5 ended up canceling both out. And then this side we have to multiply, so we get 5x. Now again, I like to bring all my variables to the left, so I'm going to subtract 5x from both sides. I know it might feel weird. This is just 0. There's nothing else over here. Negative x plus a negative 5x is a negative 6x, and this 12 is still there. Then we have to move the 12 to the other side, so we're going to subtract 12. So we get negative 6x is less than or equal to 0 minus 12, negative 12. And my last step, divide both sides by negative 6. This time, you are dividing by a negative, which means you flip your inequality. Should be a positive 2. So I'm looking for when x is greater than or equal to 2. And because it's allowed to be equal to, this should be a closed circle on 2. Let's go up and look at 2. So there's a closed circle on 2, which it could be either one of these, but I wanted to be everything that was greater than or equal to 2. So everything that's greater would be shading this way. So this should be C. Okay, so you can review those and check those out. There's a lot of good solving that's happening on this section. I would make sure that you can solve each one of those by hand. You're going to have to know how to do each type. I will do just a few more here in case people want to see those. So like I'll throw a couple up here real quick. And I'll do okay. So let's look at these two. So in the first one, what should you do first to solve? Oh yeah, get rid of that fraction. Multiply both sides by 7. Okay. When I multiply both sides by 7, this 7 cancels. That was the whole point. So I get 8x minus 3. This side, I have to multiply 70. I'm going to keep my x's on the left. So I'm going to add the 3's. I get 8x is greater than or equal to 73. And this one, it doesn't come out nice, guys. So just leave it 73 over 8. Just leave it as the fraction. Now, if I had to graph this, I would have 73 over 8 on my number line, which, just so you know, 73 over 8 is a little bit more than 9. So it's about 9.125. Okay, so would this dot be open or closed? Greater than or equal to? Since it can be equal to, it should be closed. And then I want everything greater, so then I would shade in the greater direction. Usually we put some other points on here, like I might put 0 just so that my reader knows that this side is the side that's getting bigger. Okay, let's do the second one. Here I'm going to distribute. So this is, whoa, that is not an 8. Yikes, I almost made a big mistake. 3 times negative 5 is negative 15x. 3 times 4, 12, greater than 7x plus 20. So remember, we like to bring our x's to one side. So we're going to subtract 7x from both sides to move it to the left. Over here, negative 15 and negative 7 add up to negative 22x plus 12 is greater than 20. Okay, then I got to move that little 12 over, so I'm going to subtract it. I get 8. My inequality stays the same, and I get negative 22x. Okay, last but not least, I got to divide by a negative 22 on both sides. Uh-oh, dividing by a negative 22 should immediately flip your sign. So then 8 divided by negative 22 ends up giving me, I can reduce this fraction. I'll show you. So if I reduce that fraction, I can divide them both by 4. Nope, I lied, 2. So if I divide the top by 2, I get negative 4. If I divide the bottom by 2, I get 11. So this is the same as negative 4/11. Okay, so let's look at it on a number line. I'm going to graph negative 4/11, and I'm going to graph 0. Now 0, since this is a negative number, 0 would be somewhere over here. Okay, guys, should we have a closed or open circle at negative 4/11. Since it's not or equal to, it should be open. And then I want everything, this reads x is less, so I'm going to go everything smaller to the left. So there would be your graph. There's your solutions. Anything smaller would work. So like what's over here? Negative 5 is over here, negative 10. Anything that's less would make it a true statement. Okay, so for your homework, which I suggest you do tonight, from lesson 20, you're doing, this is important, you're only doing 1 through 4 and number 10. 1 through 4 and number 10, and you're putting those on Learn Zillion. All right, good luck. If you need to rewatch these to help you, you can, and I will see you in class on Thursday. Don't forget your mid-unit assessment is due Wednesday by midnight.